How you doing? We are in chapter 3. We're looking at section 4. We're going to talk about multi-step equations. So our first vocabulary word is to work backwards. And basically working backwards, I think it's pretty self-explanatory, but it is one of many problem-solving strategies that we should use. So one of the things that we need to make sure we could do is to draw a diagram, make a table or chart. Basically, we're trying to organize our information in all of these different activities, these different approaches, in order to solve the problem. Use a graph, check for hidden assumptions, guess and check, model. And guess and check is a funny one. We talked about it in class, but guessing and checking isn't guessing and checking with your teacher or guessing and checking the back of the book. It's guessing and performing mathematical operations to see if your guess made sense. Act it out, list the possibilities, identify sub-goals, look for patterns, eliminate possibilities. All of these are things that you do naturally, but if you think concertedly about doing them when solving a problem, they become a strategy that's really, really helpful. So make sure you keep an eye out for these different strategies that might be helpful for you. Let's finish with our vocabulary. So we took care of working backwards just by recognizing that it is a strategy for solving equations. The next one is multi-step equations. So we have been dealing with equations that were like one step or maybe two step, but multi-step equations requires you to do several things before solving. So right here I am showing you an example of, let's make this a 7x, of a multi-step equation minus negative 3x minus 1. This would be a multi-step equation because it requires many steps. You're going to have to do distributive properties, simplify both sides, move things around, blah, blah, blah. So that's what's happening when we think about multi-step equations. The next idea is consecutive integers. And consecutive integers is really associated with the idea of number theory, which is the theory of numbers and how they behave. A concept of number theory would be like trying to figure out what type of integers add up to give you an odd number. I'm going to give you a second to think about it. Second done. So if you had to think about what kind of numbers give you odd answers when you add them up, well, you can do a little something plus something gives me an odd answer. What would it be? If you're thinking only evens numbers, does two even number add up to an odd number? No. How about an odd plus an odd? Think about it. No. It must be an even plus an odd. So these are some of the ideas and concepts that are discussed in number theory. But back to consecutive integers. Consecutive integers, the word consecutive means one coming right after another. So if I have consecutive integers, then I might start off with a number like 1, and then the next number is 2 and 3 and 4. Pretty basic, right? I could even talk about consecutive odd integers, and that might be 3, and then the next one would be 5, and the next one would be 7. Notice they're numbers that come right after another, and if you want to deal with it, consecutive even integers could be 78. What comes next? You got it. 80. And then 82. So you can have several, more than 3, even though I only wrote 3 different consecutive numbers each time. But when you're talking about this in terms of a variable, if I'm talking about just consecutive integers, I'm going to start off with one variable value that's x. The next number is not y. The next number would be x plus 1. Because think about it, if x were like 3, to get to the next number, which is 4, you'd have to add 1 to 3. And what would the next number be if we were talking about consecutive integers? Hopefully you realize it's x plus 2, then x plus 3, then x plus 4, for however many consecutive integers you're dealing with. Here's the thing that many students do forget or get confused about. When you're talking about consecutive odd or even numbers, you always have to skip one. So let's say I'm talking about consecutive even, for example, and I'm starting off with a number like 16. I don't want to move just to 17 by adding 1. I want to move to 18. What number would that be? X plus 2. If I'm thinking about the next number, it would be x plus 4. Notice I have to add 2 each time I want to move to the next consecutive even integer. But the thing is, that's exactly the same as if I want to move to the next consecutive odd integer. Let's say I start off at 17, and that's an odd number. The next odd number is 19. If x were 17, how do I get from 17 to 19? I've got to add 2. So when we're talking about consecutive integers, oftentimes we'll refer to consecutive odd, consecutive even, or simply consecutive. You need to know how to use the proper variable representation for that, and that's what we just discussed. And that's it for vocabulary. Let's go ahead and work on some examples. Recently, we just did a problem. Do you remember Marcella's Bagels? We did this problem where this child was walking down the street with a bunch of bagels and she's sharing it with people, and then she gets home and there's only 2 left. And we had to kind of think through how did we get there. One of the processes that we can use, and we're going to use that here, or one of the processes that we should have used, is working backwards. So here's the story. We have, after cashing her check, Tara paid her father $20 that she borrowed. Then she spent half of the remaining money on a concert ticket. She bought lunch for $4.35 and then had $10.55 left over. What was the amount of the paycheck? So we can work backwards. We should start off with the amount that she had left over. She had $10.55. After that, well, before that, just before that, she bought lunch for $4.35. So now we need to add that on. And when we add that together, so that means she had $14.90, right? But what happened just before then? Just before then, she spent half of her money on a concert ticket. So she must have had double this in order to spend half to get this left. Does that make sense? So what I'm going to do is take 14.90 and multiply that by 2. So before she bought that concert ticket for $14.90, she had $29.80. What did she do just before buying that concert ticket? She repaid her dad $20. So that means that was $20 subtracted from her. We need to add it back on. And so when we add $20 to $29.80, we get $49.80. So her check was for $49.80. Make sense? I hope so. The pun was intended. Makes sense. Yeah, never mind. All right, next problem. So we're going to now use our skills at solving equations. That was a terrible line. To solve some of these equations here. So this is what we got going on. We're going to solve this and we're going to check our answer. What we want to do is, I like to think about isolating a particular variable. In this case, I'm all about getting m by itself. So if I want to get m by itself, there's going to be a side of the equation where I'm going to leave my m terms and the other side where I'm going to put my constants. So if I want my m terms over here, what needs to go is this negative 17. I can take 7m minus 17, and on both sides of the equation, I'm going to add 17 because I'm doing the opposite, right? When I do that, I get left over here 7m, which is the m term, which is awesome, and then 60 plus 17 is 77. The next step that I'm going to do is now I want to isolate this variable. You remember when we did these problems, when we were solving equations by multiplication or division, you know what we got to do? We got to divide it. So I'm going to divide both sides by 7, right? Who's bothering m? 7's bothering m. How is 7 bothering m? By multiplication. What's the opposite of multiplication? Division. So I divide both sides and I get that m is equal to 77 divided by 7 is 11. So how do I check that? I take the original problem and I'm going to plug in that variable 11. 7 times 11 is 77, minus 17 equals 60. Let's hope that we get 60 on this side. 77 minus 17 is 60. Woohoo! I'm feeling good about myself. Let's go ahead and do another problem. So here we have t over 8 is plus 21 is equal to 14. Same thing. I'm going to get my t term on this side. I'm going to get my constants over here. And so I'm going to leave this guy, get rid of this guy. I'm going to add a negative 21 to both sides. This time, instead of doing it horizontally, I'm going to do it vertically. So when I add the opposite, that goes away. And I'm left with t over 8 is equal to, well, this is a positive 14 plus a negative 21. I subtract and take the sign of the higher. I get a negative 7. So oftentimes students get a little confused here and they'll say, oh, what am I supposed to do? Divide by 8? Not quite. Who's bothering t? 8's bothering t. How is 8 bothering t? By division. What's the opposite of division? Multiplication. So I'm going to multiply myself out of this mess. So when I multiply, I did it so I can cancel that out. T is equal to negative 7 times 8, which is negative 56. Now it's checking time. I take the original problem, I write it down, and I'm going to replace the variable t with the number negative 56. And I know that when I have a problem like this, I got to do the division first before addition. So negative 56 divided by 6 is a negative 7. Remember, negative divided by a positive is negative. Plus 21, hopefully this is 14. And when I add it together, woohoo, it's 14. And my checking is done. In this equation, we're going to do the same thing. We're going to try to solve. But the thing about this is that when you have a division, we talked about this a little bit before, this is a grouping symbol. By having the division bar, it kind of groups all of the p minus 15 together. So I need to start unpacking this in a sense slowly. So let me rewrite this really quickly and let's talk about how we're going to get through. So the first thing is, it's almost like this is a tough nut to crack. So I need to get rid of the 9 before I can even venture to get rid of the negative 15. What is 9 doing to the thing that I want to deal with? It's dividing. What's the opposite of division? Multiplication. So I'm going to multiply 9 out of my life. Got it? And when I do that, I get p minus 15 on the left, and on the right, I get a negative 54. And so now I can isolate p just the way I usually would. I'm going to isolate p by getting rid of the negative 15. Who's bothering p? Negative 15 is bothering p. How do I get rid of it? By adding the opposite. So I'm going to add a positive 15 to both sides. When I'm done, I get that p is equal to negative 54 plus 15, which is going to be p equals negative 39. So we get negative 39 for that, all right? Over here with example 5, we're going to write and solve a multi-step equation. So we're going to write an equation given the information below. So let's make sure we do this carefully. 2/3 of a number minus 6 is negative 10. Well, they kind of gave us that really nicely straight out. So 2/3 of some number, let's call that number n, minus 6 is going to give me negative 10. And so we're going to do what we do. Let's get our n terms on one side and our constants on the other. Get rid of this 6 by doing the opposite. You're going to add the 6 to both sides. And then we get 2/3 n is equal to negative 4. How do I undo what's happening to n? N is being multiplied by a fraction 2/3. How do I undo what's happening to n? I multiply by the reciprocal, right? That's how you undo multiplication with a fraction. So those cancel out, and I get that n is equal to negative 4 over 1, writing that as a fraction, times 3 over 2. I can cross cancel. I can do all kinds of cool things. I'm just going to multiply straight across just for kicks and giggles. I get negative 12 over 2, and that's negative 6. So that is my answer. They didn't ask me to solve, but since I'm awesome, I'm about to, they didn't ask me to check, but since I'm awesome, I'm going to check. So negative 6 goes there, minus 6 equals negative 10. Notice I rewrote the problem. I'm just plugging in values. Multiplication supersedes subtraction. So 2 over 3 times negative 6 is really going to be 2 over 3 times negative 6 over 1. When I do that, I get a negative 12 over 3 minus 6 equals negative 10. I get a negative 4 minus 6 equals negative 10. You remember keep, change. Minus 4 plus a negative 6 is an equivalent way of writing that. Negative 10, and negative 10 is equal to negative 10. And I'm done. Example 6. So we're going to solve a consecutive integer problem. Let's go ahead and take a look and think about some of the things we talked about earlier. Write an equation for the problem below, then we're going to solve the equation and answer the problem. Find 3 consecutive even integers whose sum is negative 42. So we've got 3 consecutive integers, 1, 2, and 3. They're even. So the first one I'm going to call x. Since they are even, I've got to skip to the next one. I can't just go x plus 1. I've got to go x plus 2 and x plus 2 more, x plus 4. So find 3 consecutive even integers whose sum is this. Well, if they're just saying that the sum is going to be negative 42, then I just write x plus 2 plus x plus 4 is equal to negative 42. Join like terms together, I get 3x plus 6 equals negative 42. Isolate this x term by subtracting the 6 on both sides. I get that 3x is equal to negative 48. Divide both sides by 3. I get that x is equal to negative 16. Since we got that x was equal to negative 16, these are the answers to the problem. I hope that made sense. Take it easy. Talk to you soon.